I just couldn't sleep at night, waiting to find out more about this weird issue with the Basic 60M Gaming X. Therefore, I purchased another 2 samples for my studies. Well, actually, it's 4 of them. And my intention is to check whether the variance in performance is actually different between different samples of CPUs. So I will test both CPUs with this motherboard and check if the scores are the same, if the undervolt that I need to, actually the overvolt that I need to apply has to be the same to get the proper scores. I will also use a different CPU cooler this time to make sure that there's no thermal throttling. I decided to use this one because it seems to be very easy to actually take in and out of the socket. And I will then add another motherboard from a different brand that I think could actually be much more efficient, and double check the results of my previous videos with the 600 PSU. So let's see. All of the CPUs are actually H0 stepping, which means the die are just 6 power cores. There is no efficient cores that are disabled on those CPUs, and you can check online articles about that. You will find out that the H0 stepping basically has a much lower power consumption. I will start with Geekbench. As you can see, it's a very light load. We're getting around 60 to 70, a peak of 80 watts. It actually shows a little bit better on the single core if you actually have clock stretching issues. We got to the multi-core part and we hit 130 watts. Now we are expecting about 1900 points for the single core. That was the best score that we got from the Asus and ASRock boards actually in the previous runs. And with the Gigabyte board we never got that far. And here it is. Here it's clearly showing clock stretching issues in the single core result. But actually the multi-core is not that far. So let's start to apply some overvolting. Let's kick off with the previous stable settings. So in the previous video, this plus 10 millivolts was all that we needed to stabilize the results and get proper scores out of the CPU with this motherboard. The first run of R23 we are not running with high priority because we want to check the temperatures, and this cooler actually doesn't seem to have like full pressure with this mount kicked, but we're still getting much better results than with the stock cooler, so I'm pretty confident that these results are gonna be more in line with each other. Okay, we are now recording with high priority on, and the power consumption is much lower than with the stock cooler, as we're running like around 20 degrees colder. And let's see if the results are in line. I'm very surprised by the resolution. It is much higher than expected. Yes, we actually got a slightly higher score. And this is quite interesting because I was expecting maybe to see a little bit more of a performance increase with the better cooler. And we actually got a huge power consumption saving. That is very interesting. Now, I want to check if maybe adding him 5 more millivolts can actually improve the score a little bit more. Let's see. Running at plus 15 millivolts, power consumption is almost the same. I would say maybe 1 watt more, 1 or 2. Let's see. As the temperature rises, the power consumption follows suit. I'm expecting 150 by the end of the test. Oh, almost there. No, you didn't get that. And let's see the score. The score is slightly like 50 points less. So yeah, 10 millivolts, exactly as the previous i5 that we got. Seems to be the sweet spot. When I was recording the previous video, I had a very low score with gigabyte 5 default settings with the basic system Gaming X. So clock stretching was playing a big part, especially in the single core score. In the single core part of this test, you don't get up higher than 75 watts, while the multi-core gets to a peak of 120, 130. And the best score that I got was actually from the ASRock and the Asus motherboards that I tested with the first comparison round up, and it was around 1900. So I'm very curious to see. With the gigabyte boards I would never get that much. Maybe now with the plus 50 millivolt I can get maybe a little bit better in the single core. Yeah, doesn't happen. It's still very good. It's still in line with all the other boards. So as a double check, I will now try to run the board at plus 5 millivolts. Setting the board to plus 5, and the results for plus 5 are in, and basically it's almost the same with Cinebench, while Geekbench shows like a tiny decrease. So it's definitely there, it's consistent. Around 5 is very hard to notice. Now that the first CPU has been labeled with a 10, it's time to test the second one. It's very surprising to see, but with minus 5 millivolts, this CPU is not showing any regression in Cinebench or Geekbench. So we will try to do minus 20 with this. Okay, at minus 20 we seem to have hit a rock bottom. We start to see a noticeable decrease in performance, and we want to validate that, so we want to test again. We're going to run another test. And we waited a little bit before running the second test to let the processor cool, even though Geekbench doesn't actually stress that much. We're running at 30-40 watts and the fan is barely spinning. With the second run we got a much better single core, but it's still the lowest that we ever hit. And so I saved some of these previous scores, and you can see that the multi-core was much higher, even though the single core is quite close. So we definitely hit the bottom. So here's the minus 5 result, and you can see the minus 5 result was slightly better in single but much better in multi-core. So there's some consistency with the multi-core score. We're now going to run Cinebench R23. As always, running R23 at high priority, and we can see clearly that we dropped at about 10 to 12 watts. We ended here, 137, but we got a very similar score actually. I am betting on this being the best setting for this CPU. And just as expected, we got the peak score for R23, and we got the peak score for Geekbench. Actually, the first run was not peak, but you can clearly see that it's higher. And we can also take it back with the -5 results again. So this is -5 and this is -10. -5, -10. And so yeah, definitely this CPU with this motherboard gets the best at -10. And while the other one was getting the best score at +10. Yes, guy, we have it. This CPU is the worst one. It clearly shows a much lower multi-core result in both Geekbench, both runs, and Cinebench R23 at the same -10 millivolts. And so it's confirmed that with Alder Lake we still have silicon quality playing a role with undervolting. So my guess now is that Intel introduced clock stretching to avoid any instability issues, and that's why they did it. Mostly, I guess. So it's not clear how they actually do that, but it's put in place to avoid any crashing, and it's still related to silicon quality somehow. There is still some binning going on inside the CPU, so he knows how much he can take and when to start stretching. So silicon quality isn't huge, it's not playing a major role. You're not getting because you can't undervolt that much, so it will not affect. It's not something that you have to look out for. It's not something that you're not gonna bin those CPUs, but it's definitely there. And yeah, tomorrow I will test 2 other boards and we will see if we get the same scores at the same 147, 146 watts of power. Asus Prime Z690M plus D4. Loading the volt options. Loading XMP 2. I hate Asus. And then setting DDR3 2400 and 18 F10. Now we have to add a Wi-Fi card because Asus doesn't include that in a Z690 motherboard, but that's a low-end Z690. But nevertheless, this was the best performing motherboard in our previous testing, so we're very curious. We loaded the 0 offset i5, the CPU. So the CPU that was running at best speed at 0 offset, the unlucky one, the low bean one. Let's see. One of the best features of Windows is that even if you're running the same exact drive, as soon as you swap the motherboard, you have to enter the password for Wi-Fi again. I just love Windows. It's just the best operating system. During the first runs, I noticed 10 watts less power consumption, but we have a very terrible single core score here, which was better in the previous run. But the multi-core score seemed very good. That's just Geekbench variance, I guess. But the multi-core scores are very nice. So I'm gonna test now with Cinebench, as always, with high priority, and that will give us much more consistent results. And here we go, and the power consumption seems identical. Even maybe 1 or 2 watts more. I had to double check the mounting pressure for the CPU cooler, which isn't making a lot of noise. But yeah, the power consumption is definitely 4 to 5 watts more than what it was with the gigabyte boards. That's very interesting. That's very interesting now. I have to say that this Wi-Fi card is probably older than the Intel cards that are working inside of the gigabyte boards. And you see this flickering is all related to the high priority run. And we got a very nice score in the end. So I have to check now for temperature, which might explain this lower score. Oh, actually the higher power consumption. So let's run again without high priority, otherwise we won't be able to see anything. With normal priority again, start Cinebench multi-core, and we see if we're going over. I think the maximum that we got was 83 Celsius with the gigabyte board. Oh, it's perfectly in line. So it's not that. It's definitely not about the power, the pressure, because that's the same as that. Maybe even like 1 C lower than what we were getting with the gigabyte board. I don't have single cores. Yeah, perfectly in line. So this cooler is doing its job with the very wonky setup, and the power consumption is like 3 to 4 watts higher. So this is in contrast with what we got with our first round of results. But I think we got the best multi-core score with the Gigabench, nevertheless. And yeah, the multi-core score is in line. So let's see now, with this CPU, we were getting lower performance as soon as we started to undervolt. So we're now gonna undervolt and see whether this motherboard is actually providing more power, which probably is the case. And yes, I'm running at a -15 with the Asus Prime, with the same CPU that was previously losing a lot of performance when undervolting, and this is definitely not doing that. We actually got like very nice single core and multi-core scores out of this board. Now it's time to run Cinebench and see how much the power consumption is dropping in line with the other board. We are now running at the same exact power as the Gigabyte board, 146, 147. So yeah, definitely. Oh, I can see the fan is spinning quite slower now. This tiny drop of undervolt actually made a huge difference in the noise. And we're now running a stable 147. So that means that basically this board has the same efficiency as the Gigabyte board. I mean, I could also try to undervolt a little bit more, but I have doubts. I mean, as clock stretching is very fast to come by, I'm seriously not sure. But I'll try. I'll try to run -40 now and see if there's any difference. Now let's check the scores. I guess we got a very good one. 1316. Yeah, that's right. We got the best scores when the undervolt is at the best. So everything seems to be confirmed. Now my gut tells me that even this is gonna be too much, but we'll see. Running R23 at -35 millivolts, power consumption dropped quite a bit, like 4 to 5 watts. Here we are. No, it didn't drop. So, so this placed this motherboard at the top again for efficiency, because we got the same exact like scores in around 2600, but we were running at like 6 to 7 watts less than the other Gigabyte boards with the worst CPU that I tested before, like actually the worst out of the two that we tested yesterday, because this one was running at -10 and this one was running at -0. Oh, I forgot to check the idle power consumption. This board is running at 23 watts idle. I think it's very low number, even considering that I'm running a very old Wi-Fi card, which could add like maybe 1 or 2 watts. So that means that this motherboard is actually more efficient in the VRM section. And well, I guess that's all. I don't want to spend more time on this. We're gonna try the MSI board next. Last motherboard, B660M Mortar Wi-Fi DDR4. First of all, I noticed that in the memory frequency selector, you get to select, I guess, gear 1 and gear 2 by the same menu. And so yeah, it seems like we're running on everything. Optimize the folds. We loaded even though we're on expert mode. There's AVX 512 support enabler. The CPU cooler is set to like no limits, and we can start. So this motherboard has a very nice layout, very nice look. It has double PCI slots, also has a 1X. This is wide 4X, and MSI mortar boards usually focus on very good VRM and just get the best bang for the buck, and they never fail to satisfy my needs for computers. If only they had a proper Thunderbolt card. They had the header. They put some headers on the motherboards, but they never released the Thunderbolt 4 card, Maple Ridge, and these are not compatible with any other brand motherboard Thunderbolt cards. So that's pretty useless for most of my builds. We'll see now whether the cooling is mounted properly. Running a very quick R23 just to see the temperature, and then we'll start with the proper testing. So it should run around 80. Oh yeah, it's running actually a little bit cooler maybe. Interesting. Yeah, everything seems fine. So we're gonna start with the testing now. And by default we're seeing the same 147, 148 watts. So it seems like this motherboard is behaving the same as the Gigabyte boards. And we will have to find out how much voltage it's actually providing, because as we saw before, the Gigabyte board was like with this CPU, this is the 0 CPU, the Gigabyte board was providing just enough voltage to get the right performance, just on the edge of clock stretching, while the Asus motherboard was using the same power but was actually providing more voltage, so it ended up being much more efficient because I was able to undervolt by 35 millivolts. Now we are now running with the mortar at 0, like default settings, and I've read something on the internet about setting some load light. Oh, we got a very nice score. That's very impressive. And for the Geekbench 5, we actually got one of the worst multi-core, but also I think the best so far multi-core score. Yeah, Geekbench is quite erratic, but yeah, so it's definitely not having any issues with the default voltage. So it's now time to go to the BIOS and check some undervolting settings. Okay, very weird. This motherboard, which I actually purchased brand new like 2 days ago, is actually coming with a very old BIOS, so I have to fix that before everything, I guess. Now time to check with the offset voltage. A tiny bit, 3 watts drop in power, and a -10, the scores were pretty much identical with a slight drop in power. So this motherboard definitely has some headroom related to clock stretching compared to the Gigabyte board. Let's now try the 35 that was working with the Prime Asus. And -35 killed the performance. And so we're gonna look for maybe a place in between, -20. Okay, running at -20 on the basic system. Running at -20, we saw a drop in score for Geekbench 5, but Cinebench kept the same. So we're gonna run Geekbench again to double check, because we got 2 very low scores for multi-core and Geekbench 5 running at -20 millivolts. But we got a very decent, actually the best multi-core R23 score at 142 watts. Okay, after running 4 Geekbench 5 and getting pretty much the same score, I'm gonna tell you that this motherboard is incredibly consistent, and I'm pretty sure that in this kind, like there's something in the workload that gets some harm by the undervolt for sure, because I was getting 9600 before with -10. Now at -20 I'm getting 9200, but Cinebench is not getting any slower, so that means that probably the part of the chip that is getting slowed down by the undervolt is not affecting Cinebench. That is very interesting, but I guess that -15 will be perfect. At -15 we're around 143 watts. 13,650. Let's now add Lite Load 1, mode 1, to the offset of -10 that we already tested to be perfectly stable. This is incredible. So MSI definitely has found a way to get around Intel lock for Alder Lake undervolting. I already tested this like with a previous build with the motor, but I didn't have the power readings to like demonstrate that, but I did for sure got the huge reduction in temperature setting load light to 1 without losing any performance or stability. And I can now confirm that. Look at this. So this is the score that you're getting. You're getting like 100 points more, and I'm getting like a huge boost in Geekbench also. I almost got to 10,000, and I was using like 25 less watt. So MSI definitely has found it, has got the solution for undervolting or Alder Lake, and it's all about load light 1. This is something I found on Reddit initially, like 2 months ago, and I can definitely confirm that it works. It just works. The power consumption drops dramatically. I'm now using I'm now using undervolt and load light together. When I first tested this, like as I told you, I already tested this in a previous build, and with that build, even -5 offset was getting me like worse performance. So I was setting -0 and load light to 1, and that got me much better temperatures. So I thought maybe undervolt is broken on MSI, and it's just and you just have to use load light instead. And maybe load light is something like -20 or -25 undervolt, and that works. But now that I have this sample CPU, that I'm sure that it doesn't take any undervolt on a gigabyte board. It does take a huge undervolt on the Asus board, and with the MSI board, I was getting like -10 instead of -35 on the Asus. But I can now say that you can mix and match load light and undervolt together. I'm now running this real time. The load, I'm now getting to the multi-core load. And in the multi-core section with the gigabyte board, I was getting around 120. With the Asus board, I was getting a peak of 110. And here, I never saw it above 100. Okay, here it is, 104. So that's still 6 watts less than the MSI, than the Asus board for this test. I saw 104 again. 106 I saw. Yeah. So we're still getting lower power consumption than actually much lower on the Cinebench. And here's the score. These are much higher scores than what I was getting. So let's get again to the gigabyte -5 score. This is like, you can see that, 9 and 8 difference. So yeah, MSI won this by a landslide in the end. And so this is my motherboard chart. And why did I put the stock cooler in the middle there? Well, because the B660M motor Wi-Fi is just so much better than the others. It's just in another league, you see? So it's also interesting because with the B660M motor Wi-Fi, therefore setting load light to 1, you could even run the CPU on a stock cooler. Maybe not the 12,600, but definitely the 500 and the 400F, no issues. And that's huge. Like, you save a lot of money like that because it's like 20 watts less, and that's entirely a different class of cooler. Remember also that with Alder Lake locked CPUs, your limit is mostly inside the package and not in the cooler itself, because I was also getting like 80 degrees, 75 degrees with the Noctua 15-inch. So it's definitely you definitely want to get a lower power consumption inside of the chip, not from the cooler. Then the Asus Prime is, yeah, it has a better power consumption. It's also very expensive. It's the most expensive in this chart, like at the same level as the Gaming X Z690 from Gigabyte, but at least it has better power consumption. It doesn't have the Wi-Fi, so. Then the DS3H is very cheap. It's the cheapest of the comparison, and all the bottom motherboards from Gigabyte here have the same power consumption. You just have to dial with the voltage a little bit differently, but they all end up in the same ballpark. The Gaming X B660M is nice to look at, but and has like a better PCI Express layout, but that's all that it has going for. And the Z690 is just expensive, doesn't have Wi-Fi, so there's nothing going for it actually. Like, yes, it's unlocked, but it's unlocked. It's full size, has a couple of PCI Express and NVMe slots, but I would never, like, I mean, yeah, there can be some kind of cheap, maybe i5 12600K, and you need a lot of PCI Express and NVMe storage, and you don't need Wi-Fi. It's very hard to make a case for the Z690 Gaming X. So yeah, MSI, huge win here. Thanks. I had the chance to make a very similar system with the i5 12500 CPU, and it's running on a simple stock cooler, so you can see it's kind of noisy, you can hear that, but the scores are so similar, and the power consumption is like 25 watts lower, and like the cost saving is incredible. You don't need to run an expensive cooler, you don't need to spend like $60 more for the 12600. You have 20 watts less peak power. The i5 12600 is just stupid compared to the 500. You don't even get a better GPU. So I would say for everyone that is in his right mind, get a 12500 and not a 600.